So this is Jeremy Clark of jeremybytes.com, and today we're going to do something a little more casual. I really haven't been following Roslyn, also known as the .NET compiler platform, and I was kind of curious why it was relevant to me. Well, I'm not quite sure I still have that answer, but at the MVP Summit about a month ago, there was a hackathon where we built code analyzers, and this made me want to explore it a little more. I'm still not sure how relevant this is to my day-to-day coding, but it is kind of a cool technology. I am definitely not an expert in this. There's lots of people who have been working with Roslyn for a long time and have been building analyzers as well. So this is basically my experience as someone who's new to this. So first of all, let's take a look at what a code analyzer is, how it works, and what we're actually going to be building today. Now, if you've been using ReSharper or some other third-party tool, you're probably already familiar with this. In this case, I'm going to build a very simple analyzer. What this will do is look for if statements in my code, and if it finds something that's not wrapped in curly braces, we're going to recommend that you do add curly braces, and we're actually going to add a code fix that will do that for you. So if we look at the code that we have now, we do see we have a green squiggly, and if we look at this, we see if statement should be enclosed in braces. Now, if we click on this, you'll see that we have a code fix, and we have a little preview window that pops up, and it says, this is what I'm going to do. I'm going to add curly braces to this. So if we choose that, boom, our code is changed. Now, it used to be that building Visual Studio plugins was extremely complicated, so there were just a few people doing that. But with the way that Roslyn works, it's actually much easier to dig into the code, find specific pieces that we're looking for, and make changes to it. And that's exactly what we're going to do today. Now, before we move on, let me just show you something that we have here. Now, I am using Visual Studio 2015. This is the preview that came out in November of 2014, and I'll show you where you can get this in just a bit. First of all, if we open up our references, we see we have this new Analyzers section. If we right-click on this, I can say Open Rule Set, and it will show us all of the rule sets that are currently installed. Now, this might look familiar because it actually includes things from FXCop. And notice the first column we have like CA1001. This is an identifier that makes it really easy to look these up online. Now this is something to think about. We'll just be using a placeholder for ours, but if we wanted to build analyzers that we distribute, we want to make sure it's easy for users to get more information on them. Now if I scroll down a little, I'll find the analyzer that we actually built, which is in the syntax section, and we can say it says if braces analyzer. So this is what we actually want to build. Now, obviously, I have a completed one that's already installed, so the first thing I'm going to do is uninstall it. As we'll see, there's a couple ways to deploy these. I actually installed this with a Vizix, a Visual Studio extension. So we can see it here, if bracesanalyzer.vizix, and I can uninstall this just like that. Now, it will ask me to restart Visual Studio, so we'll go ahead and do that, and I won't save changes. And this brings us back to the code that we started with. And as you can see, we do not have any squigglies at this point because we uninstalled that analyzer. So before going on, let's look at the tools that we need. The easiest place to find these is at the Roslyn Codeplex site. Now, Microsoft has been moving a lot of things onto GitHub, so this site might move in the future. But for now, if you go to roslyn.codeplex.com, you'll find the information and downloads that you need for the .NET compiler platform. And if we scroll down just a bit, we'll find the pieces that we want. So we can see that there's 4 things here. First, we need a copy of Visual Studio 2015 Preview. We also need to install the Visual Studio 2015 Preview SDK. And we need a couple of Vizix packages, one for the SDK templates and one for the syntax visualizer. The SDK templates will give us something really easy to start with so that we can modify an existing analyzer rather than starting from scratch. And the syntax visualizer is very important, and we'll see that as we go along. Now, if you click on these links, it will take you to the downloads that you need, and it doesn't matter what order you install these other items in. So we can see I have the Roslyn SDK project templates, the Roslyn syntax visualizer, and also the Visual Studio SDK. And to install these, we just double-click and follow the instructions. So before diving in and figuring out all the pieces we need to build our own analyzer, let's see what we get from the template. So for this, I'm just going to start a new project. So we'll say File, New Project. And if we go to the Extensibility section, we'll see that one of the options that we have is Diagnostic with Code Fix. And notice it says NuGet plus Visix. Like I said, it'll give us a couple of different deployment options here. So this is what I'm going to choose, and we'll go ahead and call this if braces analyzer. And it'll take just a minute to build that solution for us. Now, as we go, I will be chopping out a few pieces. We're going to be debugging into Visual Studio and doing some other things that take a long time. So I'll be making things a little bit shorter for this video. Now, the nice thing about this particular template is it has a lot of information for us. This actually has an analyzer that's already pre-built, so we can go in and just make modifications to it. It also has things set up to build a NuGet package and a Visix for this particular analyzer. Now, I'm not going to go into the details of NuGet because you can follow the instructions here. We'll just be using the Visix and debugging into Visual Studio to do our testing for this. The other nice thing about this project is it opens up the two files that we need. So we have the Diagnostic Analyzer file, and this contains our actual analyzer code. And then if we do have a code fix, there's a code fix provider as well. Now, as you can imagine, we might not be able to provide code fixes for all of our situations. So we might not have a code fix. In our case, it's pretty easy to do, so we'll go ahead and implement that. Now, this particular analyzer is extremely simple and not very useful. What it does is says that all of our types should be in uppercase. Now, to show this in action, I'm going to go ahead and start this without debugging. Again, debugging into Visual Studio is a bit slower, so we'll just start it without debugging to make things a little faster here. So this does open up a new version of Visual Studio, so let me go ahead and open up that same file that we had earlier. Now, I did cut out the waiting part there because it does take a long time for this to start up. But if we look at our class name, notice that we do have a green squiggly here. And if we hover over it, it says type name program contains lowercase letters. And we can look at the potential fixes. And we can see one of those fixes is to make it uppercase. Again, not an extremely useful analyzer, but there you go. The good part about this is it does have things in place so that we can follow the template rather than starting from scratch. So let's go ahead and put this back and close our copy of Visual Studio. Now, before making any changes at all to this analyzer, we need to first figure out how are we actually going to perform this task that we want. We need to do a couple of things here. First of all, we need to find the if statements that are in our code. Secondly, we need to find the statement bodies that do not have curly braces around them. Now, if you think about this as simply parsing text, this could be really, really horrible. But fortunately, we have the .NET compiler platform to help us out here. So what we're going to do first of all is visualize the sample code that we have here. So since I installed the syntax visualizer, I can come to my View menu, choose Other Windows, and then choose the Roslyn syntax visualizer. And this will open up a new window where we can view the syntax tree. Now here's a warning, once we start clicking on things, this is going to be pretty daunting. And notice when I select things, we do see the selected item moving around in the tree. So here's the var. And notice there's also leading white space and trailing white space. And all of the numbers that are in the tree are the position numbers in the actual source code file. Now, the nice thing about this is this means that we can recreate the source file from this tree, including all of the white space. And that means we can go in both directions. We're not simply parsing the code, we can also generate it as well. Now, like I said, this does look a little daunting, but let's click on this if here. And notice that what's highlighted now is the if keyword. Now, if you see the blue and the green and the red, there is a legend up here, and this will tell us what everything is. So green is a syntax token, which means the actual keyword itself. Blue, right above that, notice there's an if statement, is a syntax node. And that node, as we'll see, is a much larger object. And notice that the maroon are the syntax trivia. So this is usually white space in the case of C#. So let's click on the if statement node. Now notice what's highlighted in our code window. It's the if statement with the conditional, as well as the expression that we want to execute. And if I collapse this a little bit, we can see the various parts that make this up. So we have the if keyword, and again, that's just the token itself. Then we have open paren, and then we have the less than expression, and again, that's where we say index is less than 0. Then we have the closing paren, and then we have the expression itself. In this case, we're outputting to the console. Now that expression is made up of some additional nodes, but we're not going to worry about those for this particular instance. Now, in order to identify where we need curly braces, we need to be able to tell the difference between an if statement that does have curly braces and an if statement without curly braces. And that's why I created this second if statement. Now, if I scroll down a little bit here, we can compare these two. Now, the beginning parts are the same. We have the if keyword, the open paren token, and then we have an expression, in this case a greater than expression as opposed to the less than expression we had before, and then we have the close paren token. But then we see the difference. Instead of an expression statement, we have a block. And if we open up that block, we will see the expression statement that's enclosed in it. So what that means when we're trying to identify the if statements that do not have the curly braces, we're looking for ones that have an expression statement as a child rather than a block as a child. Now there is another way of looking at this as well. If we right-click on this, we can say View Directed Syntax Graph. And don't let this scare you. So this is the syntax for just the if statement itself. Let's zoom in on this so we can see it a little bit better. So here we can see things a little more visually. So we do have the if statement at the top. Then we have the greater than expression. And notice that we do have the open paren token and the close paren token on each side of that. And then that greater than expression consists of an identifier name, the greater than sign, and the numeric literal expression. And notice we do have all of the white space trivia as well. And if we go to our block, we can see that it does contain an expression statement. And there's a lot of pieces that make up this syntax. So there are a couple of different ways of looking at this. So again, we're looking at one with a block and one that just has an expression statement as a child. So these are the things that we're going to be looking for when we're building our analyzer. So let's pop back over to our analyzer project. Now, one thing I am going to do is I'm going to come over to our code fix provider and comment out a little bit of code for now. Right here where we're registering the fix, I'm just going to comment that out with a Control-K-C. The reason for that is that we're going to build the analyzer that finds the problem before we build the fix for it. And if I don't comment that out, then that will leave that uppercase fix that we had before, which is totally not applicable to what we're doing. So without that, we have an analyzer that does not provide a code fix, but this is still useful because it can alert us to potential issues in our code. So let's start by setting up the analyzer itself. Now notice the constants that we have at the top of this file. The diagnostic ID just defaults to the name of the project that we created, if braces analyzer. But this is what shows up in that column with the identifier. So when we were looking at it before, we had CA1001. And again, that can be a good way to uniquely identify an analyzer so people can find more information online. In this case, we'll go ahead and leave this default value. Now these other things, the title and the message format, these are things that are going to show up in the pop-up. So let's go ahead and change these. So for the title, we'll say if statement needs braces. Now before I change the message format, I want you to notice that there is a placeholder in here. There is a way to pass in parameters so that we can display that as part of the message. In our case, we won't be using that. So for our message, we'll just say if statement should be enclosed in braces. And then we have the category. Now, when we were looking at things earlier, we saw that our analyzers were in different categories. So in our case, this is a syntax analyzer as opposed to a naming analyzer. So we'll put this in a syntax category. Now, all of these constants get put together into this rule. This is what we're actually building. So notice that we do have the diagnostic ID, title, message format, and category all included in this constructor. Another thing you might want to look at is this diagnostic severity. Now notice we do have different severities to choose from, whether it's an error, hidden, info, or warning. We're going to stick with warning for ours. But if we did want something that could potentially stop compilation, we could set that to error. Now, analyzers can be incorporated as part of your build process, and the way that we have build process set up is to usually stop if it runs into an error. Now, once the analyzer is installed, the user can change the severity up or down, but we want to make sure that we have a good default in here. The last parameter here tells us whether it's enabled by default, and again, we'll go ahead and leave this as true. Now, we do need to make a few changes here. Down in our initialize method, this is our analysis context. So this is where we say, this is the kind of thing that we're looking for. And in this case, notice that we have context.register symbol action. So we're actually looking for symbols because in this case, again, the default is looking for the actual names of our types. And notice that one of the parameters here is symbol kind, and that says that it's looking for a named type. Now the first parameter, analyze symbol, this is the actual code that will run to determine whether we're going to alert the user based on this particular analyzer. So I'm going to start by making a few changes here. Instead of register symbol action, we're going to say register syntax node action, because we are dealing with the syntax node, that if statement. And so we do need to update our syntax kind. So rather than being symbol kind.named type, this will be syntax kind dot, oh boy, that's a lot of things to choose from. Well, if we go back to our sample, notice that these are if statements, and there is actually a kind for if statement. So we can say symbol kind dot if statement, and this will actually just look for if statements that are inside of our code. So this analyzer will only apply to those particular nodes for if statements, and it will ignore everything else. This is our first level of filtering. Now you'll notice that our register syntax node action is not happy at this point. That's because we actually need to update our method as well. So the first thing I'm going to do is just rename it. So instead of analyze symbol, I'm going to say analyze node. And then the real problem with this is the parameter that we have. So this has a symbol analysis context, which won't work for us since we're dealing with syntax nodes. So we need a syntax node analysis context. So with that, we can see our register syntax node action is now happy. But now we have to go in and actually figure out how to identify this if statement that we care about. Now I can't really make use of much of the body of this method, so I'm just going to delete it all. But you might want to keep an eye on the lines where we're creating the diagnostic and then reporting it down at the bottom. We're going to be following those same steps, but our parameters are going to be quite a bit different. So let's just go ahead and delete everything in here for now. Now the first thing I want to do is get a reference to our if statement. And we can do this because this is actually coming in through this context. So context.node will be our if statement. Now, if we look at the type of var here, we'll see that this is a syntax node, but we want to deal specifically with if statement syntax. So we can go ahead and cast this. So we'll cast this to if statement syntax. Now, one thing about code analyzers is we want these to fail fast. If we find a block of code that we do not care about, we want to eliminate it as quickly as possible. Think about this. These analyzers are constantly running. That means that if we have a lot of analyzers doing a lot of work inside of these analyze node methods, we could end up slowing down Visual Studio way too much. So what I want to do first of all is see if the if statement has a block as a child element. And if it does, I just want to exit out because if it has a block already, I don't care about that one. Now there is a fast way of doing this, but I'm going to show you the slow way first, just to show you some things that we can do with Roslyn. Since this is a tree structure, we can actually use link to walk through the nodes. Let me show you what I'm talking about. First of all, let's see if we can find a block statement. So we'll create a block statement here, and I'll start with my if statement. And we'll say dot child nodes. Okay, so if we look at if statement child nodes, that's going to be all of these items at the top level. So if keyword, open paren token, less than expression, close paren token, expression statement. And then for the bottom one, again, the difference is that we have a block instead of an expression statement. So if I find a block as an immediate child of our if statement, that means that it already has the curly braces and we don't care about it. So what I'm going to do is look at the child nodes where the node is a syntax kind of block. So what this will do is it will look through all of the child nodes and find any that are of type block. That means it will ignore all of the other ones that we have. Now there could potentially be 0, 1, or more of these. So what I'm going to do is say dot first or default. So by doing this, we ensure that block statement is a single value, which is hopefully this syntax node. And if it can't find it, then the or default will give us a null back. And just to be safe, I'm going to cast this as a block syntax. So what this means is that var is of type block syntax, and so it will either have a valid block syntax or it will be null. Now, if we do find a block syntax, meaning it is not null, that means it already has curly braces and we don't care about it. So I'm going to say if block statement is not equal to null, return. So again, this will exit out of our code analyzer as soon as it finds that block syntax inside of the if. Now, if the block statement isn't there, that means that we do have an expression statement that we do want to wrap in curly braces. So we have to locate that as well. So I'm going to say non-block statement, and we'll do a similar query. So we'll say if statement.childNodes.where n is kind syntax kind.expression statement. And then just like before, we'll say first or default as expression statement syntax. So now we have a non-block statement, which is an expression statement syntax. And if we go back to our tree, we'll see that expression statement is a syntax node. So this is expression statement syntax. And then we'll do another quick check to make sure that this is not null. So if for some reason we have an incomplete if statement, we want to be careful of that as well. So if non-block statement is null, then we'll return. Now off the top of my head, I can't think of a situation where that would be the case, but we want to make sure that we don't end up with exceptions inside of our analyzers. So if we've gotten to this point, we've identified our non-block statement is in fact an expression syntax statement that needs to be wrapped in curly braces. So now we can actually report that back. So first we'll create a diagnostic. And to do this, we'll say diagnostic.create. And then what this wants is the diagnostic descriptor as well as the location. Now we created a diagnostic descriptor above, which we call rule. And again, that has our diagnostic ID, the title, the message format, the category, the severity, and whether it's on by default. So we can just pass rule in here. And then it wants a location. This is the location that's going to be highlighted by the squiggly lines. So let's go back to our syntax tree. Notice that our expression statement that we currently have highlighted does have some numbers after it, 304.340. Those are the character locations for our highlighted expression statement. And since that's what we want underlined, we can just take our non-block statement, which is again that expression syntax, and say .getLocation, and that will return us the location of that particular statement. Now the last thing we need to do is report back to our context. So we're going to say context.reportDiagnostic, and then pass back this diagnostic element that we just created. And this is actually all we need to do to create the diagnostic. So walking through this again, first we take our context, which is coming in. We cast the node to an if statement syntax. Then we can use the child nodes to see if there is a block syntax as an immediate child. If there is a block syntax, then we return. Now, if there's not a block syntax, we keep going and we look for an expression statement that's a direct child of the if statement. And if we don't find that for some reason, we exit out. But if we do find it, we create a new diagnostic and we report it back to the context. So now we can run this. Now, one thing to note is that in our solution, our if braces analyzer.physics is our startup project. So when we run this, what it's going to do is start a new instance of Visual Studio, install that extension, and then we can use it. Now, starting up Visual Studio is kind of expensive, so this process is a little slow. So I'm going to cut out some of the waiting for you so you don't have to watch. Okay, and if we wait long enough, notice that we do have the green squigglies underneath our statement. And if we hover over this, we'll see if statement should be enclosed in braces. Now notice it's not offering to fix it for us, and that's because we haven't provided that fix yet. But if we do actually put in curly braces on our own, then we'll see that our analyzer says, oh, everything's okay, and it will actually disappear. And as a reminder, let's go back to our references, and we'll right-click on Analyzers and choose Open Rule Set. And since we said this is a syntax analyzer, it shows up in that category, and we can see the ID if braces analyzer, the name if statement needs braces, and we can see that this is set up as a warning. Now we can enable it or disable it for this particular project, and we can also change the level that we have. So if we want to change it to info rather than warning, we can do that on a case-by-case basis when we're actually using the analyzer itself. So let's go ahead and leave this as a warning. And so I'll just close this without saving changes. So what we see here is this is pretty interesting. If I take out the curly braces, we will get our analyzer showing up saying, hey, you need curly braces around this. Now our next step would be to create a code fix for this, but before going on, I want to optimize this code a little bit. Now, like I mentioned, I'm still fairly new to Roslyn, so I'm learning the secrets as I go along. So the code that I have here that's actually looking at the child nodes and running a link query on them, it works just fine. But there's a faster way that we can do this. The if statement actually has some properties that we can use. Now let's go back to our tree. We'll pull up our if statement, and then you'll notice there's this property section down here. Well, if I scroll down, there's a statement. And we can see this statement looks like our expression statement. So console.writeLine less than 0. And if I click on the other if statement that has the block in it, and scroll down to statement, we'll see that it does include the curly braces as well. So it is that entire block. So that means rather than going through the child nodes and looking for specific elements, we can just use the statement property directly on the if statement. And this is one of the main reasons we wanted to cast our context node to if statement syntax. So let's start out with this block statement. Again, we want this to run really quickly because if we can identify that an if statement already has this block, we want to exit out as quickly as possible. And there's an easy way to do this. We can just say if statement dot statement dot is kind syntax kind dot block, then we know that our statement is a block and we don't need to do anything about this. So we can simply return. Now this has a huge advantage. We're not actually querying the child nodes like we were doing before. Instead, we're accessing a property directly, and this is going to be much, much faster. And as you can imagine, we can do something similar with this non-block statement. So rather than running a query, we'll say non-block statement equals if statement dot statement as expression statement syntax. And we'll go ahead and keep in if non-block statement equals null, return. Because again, if the statement is not an expression statement syntax, that as will result in a null. So we've just eliminated 2 link queries that would require iteration through the child nodes. Instead, we're accessing the statement property directly. Now, as you explore the different syntax nodes, you'll find these properties that are really useful in the code that we're going to write. And again, our goal here is to run as quickly as possible. Let's go ahead and get rid of these comments so that we can see how compact our code actually is. So this is pretty impressive. In these 6 lines of code, we've been able to locate if statements that do not have curly braces. And this is much easier than parsing the text of the code itself. Now let's go ahead and run this again and just make sure that everything still works as we expect it to. And again, I'll cut out a bit of the waiting here. Okay, and after waiting a bit, we can see that our code analyzer does still work. So it does still identify our if statement that needs curly braces. And if we were to wrap this in curly braces, we'll see that our warning does go away. Now, rather than having something that we have to do manually, I would like to have an automated code fix. And this is where we fill in the code fix provider. So let's go back to our project and do exactly that. So back in our analyzer project, we'll go over to the code fix provider. Now remember, I did actually comment out the thing that registered the fix because this was the fix for the analyzer that we're replacing. Let me go ahead and uncomment this because we'll use this as a starting point for creating our own code fix. Now let's take a look at what we have here. If we scroll up a little, we'll see that we do have an attribute to export the code fix provider, and we can see it's called if braces analyzer code fix provider. And the languages for this is C#. Now we can create VB analyzers and fixers as well, but since I'm in the C# world, I'm not the best person to ask about that. Now we'll be able to keep a lot of this code because a lot of this is just registering the code fix and also figuring out the spans that we're dealing with. So if we look at this here, where we're looking at this declaration, we can see that it's going through and it's finding the token based on the start of the diagnostic span, and it's looking for type declaration syntax. Well, type declaration syntax is not what we're dealing with here. We're actually dealing with the if statement syntax. So we'll need to modify this. So we'll change this to if statement syntax. And so what this does is it finds that if statement node that we've said is a problem based on the analyzer. Now to register the fix, we'll need to make a few changes here. First, when we create this, we want to add something that will be a little more descriptive. So here we'll say add braces. That will tell what this code fix is going to do. And then this lambda expression is the method that we want to run. Now make uppercase async. That really doesn't sound like the best name for our method. So I'm going to rename this to add braces async. Now, one thing to note is that this is not happy because that declaration is now an if statement syntax. It's no longer a type declaration syntax. So we actually need to change the signature of our method as well. So instead of type declaration syntax, this will be if statement syntax. And we'll just give this a better name. We'll just call this if statement. Now this is all happening asynchronously because we definitely don't want to lock up our Visual Studio thread. And so that's why we have cancellation tokens and other things in place. Now normally we don't have to worry about changing these. We just need to modify this a little bit so it works with the fix that we're trying to create. Now one other thing that I'm going to change is rather than dealing with a solution, we're dealing with a document. And the difference is that we're just dealing with one document that has the if statement in it. Now think about what was here before. It was changing the name of a type. If you change a name of a public type, it could potentially impact other files and projects in the solution. So the code fix that was here when it was dealing with changing the name of the type wanted to work at the solution level. In our case, we're just working at the document level. Now we could look through and see what was here before, but I'm basically just going to delete all this and we'll start over. So what we want to do is take our if statement, and let's go back to our tree, find the expression, wrap it in a block, and then put it back into our if statement. Now all of these nodes are immutable, which means what we'll be doing is creating some new nodes and replacing some elements based on what's there, but we will be creating new objects as we go. So the first thing that I need to do is get the non-block statement, that expression syntax statement that we want to wrap. So we'll create a non-block statement just like we did before, and we'll take our if statement, which is the parameter coming into our method, dot statement as expression statement syntax just like we had earlier. Now what I want to do is create a new block statement. So we'll create a variable called new block statement. And to create this, we'll use the syntax factory. Now the syntax factory allows us to create all kinds of things. In this case, we want to create a block. And if we look at the parameters for this, it lets us put whatever statement syntaxes we want in here. Now we already have a syntax statement, our expression syntax statement, so that means we can put our non-block statement right in here. And what that will do is create a new block with the contents of our original statement. So now what we need to do is create a new if statement that we're going to use in our document. So for this, I'm going to say if statement dot replace node. Now what replace node lets us do is swap out one node for another. And that's exactly what we want to do in this tree. We want to take this expression statement that we had before and replace it with this new block statement that we just created. So I can say non-block statement, please replace with new block statement. And you can see we have a bit of a problem here. That's because if we look at this signature, we need the old node and the new node to both be of the same type. But our old node is an expression statement syntax, and our new node is a block syntax. Well, they both happen to be syntax nodes, which means that we can cast them to syntax node, and they'll both be happy. So what we're doing is we're swapping out one syntax node for a new syntax node. Now again, when we do this, it does not change our original if statement. Replace node instead returns a new if statement syntax. So we're actually creating a new object here. We're not modifying any existing ones. So now that we have this new if statement, we need to get it into our document somehow. And this will work very similar to how we did this. We'll create a new document and return that. So first we'll get our root. So for this, we're going to await document.getSyntaxRoot async. So that will get our entire document back. If we were to go back to our tree, that would be way up here at this compilation unit. And now that we have this, we can create a new root. So we'll create a new root. And for this, we'll say root.replaceNode. And we'll replace our old if statement with our new if statement. And again, replace node doesn't modify the existing root. It will return us a new one with the new elements in place. And finally, we need to create a new document. And this will be document.withSyntaxRoot of our new root. So that will give us a new document. And then we'll just return that new document. And let's just build to make sure that we don't have any build errors here. Okay, and we have a build succeeded. Let's just walk through this code one more time. So the first thing we're doing is we're taking our if statement, which is coming in as a parameter, looking at its statement property, and casting that to an expression statement syntax. Again, this is our statement that does not have curly braces around it. Then in our next step, we use the syntax factory to create a new block node, and that block node will wrap our non-block statement. So it will wrap our statement that needs the curly braces. Then what we need to do is swap out the non-block statement for the new block statement. And we do that by using the replace node method on the if statement. And again, this does not modify it. It will return us a new one, and that gives us our new if statement that we have here. And then we need to replace that if statement in our document. So we'll go ahead and get the root, and then we'll replace the node, the old if statement for the new if statement. And again, that doesn't modify the original root, it gives us a new one. And with that, we can create a new document with the new root and return that document. So let's go ahead and run this and see what happens. And again, we'll start without debugging. Generally, I like to start without debugging because starting with debugging, where we're debugging into Visual Studio, is very, very slow. So if we can start without debugging and everything works, great. If it doesn't, we can start with debugging and step into our analyzer code. And again, we will need to wait a bit here. Okay, we can see that our code analyzer is working. Now when we hover over this, notice we do still have our message, if statement should be enclosed in braces, but we also have the little light bulb and a note to show potential fixes. And if I were to just click into this line, the light bulb does show up over here in the gutter as well. So let's see if our code fix works. So we'll pop this open and we see there's an option for add braces. And so let's go ahead and click that. Okay, and our outcome isn't quite as pretty as I would expect. Notice that our curly braces are simply flush left. That's a problem. I don't really like that. Now I can use the keyboard shortcut and go Control-KD, and that will format the code, but I want my code fix to be formatted as well. So let's see what we can do about this. If we go back to our syntax viewer, we notice that we do have all of this trivia, right? So we have the end of line trivia and so forth, the leading white space trivia. And so, for example, after our semicolon, we have end of line trivia, which means we have a line break. And then after our close paren token, we do have some end of line trivia. And we do have some leading white space trivia here. We can see that leading white space is in front of the console. Now, it would be a real pain to try to go through and calculate, okay, where are the spaces? What level of indent are we at? Fortunately, we don't have to figure any of that out. Let's go back to our analyzer, and here's our code fix provider. And this is something that you will want to pay attention to. So when we create our new block, one of the things that we can do is add with additional annotations. Now I'm going to go ahead and put this on the next line so that it'll be easier to read. And then in here, we can add a set of parameters that will have syntax annotations. Now, one of these is a formatter annotation. So I'm going to type in formatter. Now notice I'm not getting IntelliSense on this. That's because I'm not referencing the using statement for this. But if I say control dot, okay, apparently Visual Studio doesn't want to help me out in this case. So let's go ahead and add this manually. So we need a using statement. So we'll say using Microsoft.codeanalysis.formatting. And if we do that, then we'll see that our formatter is now lit up because it's a real type. And I can say dot annotation. So what this is doing is it's adding a formatter annotation when we create this new block statement. So let's see what that actually does. Let's go ahead and rebuild and run our application. Okay, and I had to wait about 30 seconds there for that to come up. So now let's go to our code fix and choose add braces. And much better, it actually figured out what the right level of indent for those were. And again, all we did was add the with additional annotations formatter.annotation. So we add a formatter annotation to this and it handles the pretty printing for us. And that's all there is to building a simple analyzer. So again, in this case, it looks for if statements that don't have curly braces. And if we hover over it, it tells us if statement should be enclosed in braces. And if we look at our fix, we can see that we can add braces right here. And it's actually possible to register multiple code fixes. So if you wanted different options of how you could implement a fix, you could put those in and register multiple fixes. Now, as you can imagine, there are a lot of places that we can go from here. This is just a whirlwind description of how to do analyzers. But again, when it comes right down to it, when we were analyzing the node, it only took us 6 lines of code to figure out if we had a spot that was a problem for the thing that we were looking for. And when we were providing a fix, again, not very much code, about 10 lines of code, and we can provide a fix. So this is much easier than if we had to build all of this ourselves. And a big thing that helps us out is the syntax analyzer. When we're looking through the syntax tree, we can see all of the different pieces of our code and try to figure out how does what we want differ from what we don't want, and how can we apply that fix. Now, there's a lot of different places that we can go with this particular fix. Another thing that we can do is make this work with else clauses. So if an else clause doesn't have curly braces, we can alert to that and also fix that. But then we have to start thinking about other things, because if we have an else if, then we don't want that else wrapped with curly braces, but we might want that containing if wrapped in curly braces. So once we start diving into this, it's not really the problem of writing the code. The problem is coming up with all of the different situations that you might encounter when you're doing this. Now, I wouldn't recommend putting a code analyzer like this into production because there's a lot of people working on these types of analyzers. In fact, Microsoft is working on getting all of the FX cop rules into the default analyzers that will ship with Visual Studio 2015. In addition, there's a number of open source projects out on the web. So, just as one example, there's a project called .NET Analyzers on GitHub, and you can see the address here is github.com/.NETAnalyzers. And this is a group of people who are working on putting together analyzers that we can all use. Now, there are a lot of different projects like this, so we'll see which ones actually end up coming out on top. One nice thing about looking at these analyzers is we can actually click into these, look at the source code, and see how people who have been working with this for a long time are implementing the analyzers. Like I said, I've only been working with Roslyn and analyzers for less than a month, so I would definitely not put this code into production without doing some more research to see what other people are doing. So code analyzers and code fixes are really kind of an interesting thing, and they're not very difficult to do. So if you want to explore Roslyn a little bit more, this is a great way to get your feet wet. By working with these analyzers, I have a much better understanding of how the syntax tree works, as well as how the semantic tree works. But I've still got a long way to go on that. If you want to get the download for this sample project, head over to my website, www.jeremybytes.com, and we'll see you next time.